Hello, welcome. In this video, we will begin to introduce graphs and applications in chapter 22. Graphs have many applications in a lot of fields. It's a very simple structure mathematically, but a lot of problems can be modeled using graphs and apply graph algorithms to solve it. For example, this is a simplified version of a map with this many cities. And we can draw a line to connect cities. Means there is a highway, for example, connecting Seattle to Chicago, a highway connecting Seattle to Denver. So this is a map represented using a graph consisting of vertices. So here, the cities are vertices, and the edges are the lines connecting the cities. The lab applications, we can ask a question, for example, what is the shortest distance from Seattle to Miami? Suppose, well, these are the flight maps. So there's a flight from Chicago to Seattle and from Denver to Seattle. So what is the minimum number of flights from Seattle to Miami? We can ask these questions, and this becoming a graph problem. Now, let's look at the basic graph terminologies now. So these are really simple terminologies. Mathematically, a graph is a structure consisting of a set of vertices and a set of edges. So this is V represents a set of vertices and E represents a set of edges. So here is this is a graph. And this is the V, and here is the E. A graph may be directed or undirected. In a directed graph, each edge has a direction. For example, in this graph, there's a direction from Peter to Mark and Jan to Mark. Now, this is called a directed graph. Now, this graph here in B and C, these are undirected graph, means you can go either way, from A to D or D to A. Two vertices in a graph are said to be adjacent if they are connected by the same edge. So here, A, D are adjacent. Similarly, two edges are adjacent if they are connected by the same vertex. So here, AC and AD, these two edges are adjacent, and they're connected by the same vertex, A. An edge in a graph that joins two vertices is said to be incident to both vertices. The degree of a vertex is the number of edges incident to the vertex. Two vertices are neighbors if they are adjacent. Similarly, two edges are neighbors if they are adjacent. A loop in an edge that links a vertex to itself. So here, we don't have this case. So if you have an edge from A to A itself, so that's a loop. Now, what is a parallel edge? A parallel edge is you have edge A to D, you have another edge A to D. So this is called a parallel edge. And so we are considering simple graphs, and there's no loops and no parallel edges. So no loops means no edge from the vertex to itself, and no parallel edges, like from A to D, now another edge from A to D, so that becomes parallel edge, no parallel edge. So if we don't have loops and no edges, no parallel edges, so there's a simple graph. We assume our graphs are simple graphs. A complete graph is like this in this figure and B. Every two vertices, there's an edge. So this is called a complete graph. Now let's look at this animation here. We can draw more edges and more vertices. So we're going to find the shortest path from 2 to 6, for example, from 2 to 6. And you can also find the depth first search tree, breadth first search tree, Hamiltonian path, Hamiltonian cycle, and find connected components, find a cycle, find bipartite sets. So we're going to look at all of this in this chapter and also in the exercises. That is all for an introduction to graphs. And next, we're going to look at how we represent a graph and create data structures to store a graph. That is all for this first two sections in the chapter. See you for the next section.